You still have it, JJ? Yeah? Yeah. Okay, cool. We're gonna go over this one. Number A. If you estimated, you got 1 point. And if you gave them the units, interpret it with units, so it had this sentence right there, that is another point for this problem. So the answer should have been the water temperature is increasing at a rate of approximately 1.017 degrees Fahrenheit per minute at time t equals 12 minutes. So that statement in general is 1 point. So you need your statements. Because you have to have the units so they know and understand what you're talking about with the units. Oh, you can't even see it. Maybe. Oh, I didn't plug it in once it's buffered. Okay. Scooching down to B, use the data of the table to evaluate the function from 0 to 20. Use the correct units and interpret the meaning of this problem. So we should have gotten 16 degrees Fahrenheit, and we need the statement, the water has warmed by 16 degrees Fahrenheit over the terminal from t equals 0 to t equals 20 minutes. Minutes seems to be the important bit also in that, in the degrees Fahrenheit. Okay, C. For 0 to 20, the average temperature of the water in the tube is, they give you an integral. Use the left sum to approximate the overall estimate or underestimate of the average temperature of water over these 20 minutes. Explain your reasoning. We should have gotten 60.79. Did we get that? So you start with the integral, which they gave us. We need to plug in our function there. We're doing the left Riemann sum. Getting that statement by itself is 1 point. Getting the approximation is another. And then we should have gotten 0.79 at the end. And then we have a statement at the bottom that we need to write to understand the reasoning. Okay, scooching it down, last one. They give us a new, find the first derivative of this function up here. Based on the model, what is the temperature at the water of t equals 25? So we're just plugging in 25 for our t from our derivative. So we should have gotten 73.043. And technically you don't need a statement for that. Integral and answer. That's all they wanted. Any questions? No. Okay. Okay, question 2. We have our graph. Hi. Yeah. Good? Okay. What? You noticed what? Oh, I think it's going around. It's the end of the year. Okay, let R be the region in the first quadrant bounded by the x-axis and the graph of y equals ln of x and y equals 5 minus x, as shown in the following graph. So find the area of R. That was the first one. That is worth 3 points by itself. So if you wrote the integrand, that is 1 point. So if you wrote just that, that was 1 point in getting that. Or you could have written that one, I guess. They gave you 2. And either way you wrote it, you got 2.986. If you round it down by 1 thousandths, it's also fine. They seem to like to do limits a lot. when I'm looking over all these answers. They like to use limits a lot. Mm-hmm. No. Mm-hmm. Number B. Region R is the base of a solid. For the solid, each cross-section is perpendicular to the x-axis, so we're cutting it this way. Is a square. Write, but not evaluate, an expression involving one or more integrals that gives the volume of the solid. So, if you wrote the integrand, that is 2 points. Expression for total volume. So I think you need the word volume at the end, and that itself is 1 point. So would you all write V equals or volume equals? Okay, cool. Bounds for the first one is A to 1. Second one is 5 to A. Last one, C. The horizontal line of y equals k divides R into 2 regions for equal areas. Write but do not solve an equation involving one or more integrals whose solution gives the value of x. Down below should have been our equation. So x, no, not x, k20 should equal 2 times 2.986 because we're dividing into 2 separate sections. Integrand was 1 point, limits was another point, equation was 1 point. Okay. Good with 2. Yeah, okay. Number 3. This is a very funky graph. Let f be a continuous function defined from -4 to 3, whose graph contains 3 line segments and a semicircle centered at the origin. Is given below, and g of x equals x to 1 of this function. Find the values from g2 and g negative 2. So g2, so instead of doing x up top, we put in 2, so that's from 1 to 2, so 1 to 2. Finding that graph. We gotta find the slope of that graph to possibly do this. Should have been -4. Second one should be pi halves minus 3 halves. That one would have been from -2 to 1. So -2 to 1. Which they flipped it to 1, -2, because you want to switch your bounds. So you have to have a negative out front. Okay. Next one. For each of g prime of -3 and g double prime of -3, find the values or state that it does not exist. They both do exist. It is 2 and 1. Each of these were 1 point. Third one, find the x-coordinate of each point at which the graph of g has a horizontal tangent line for each of these points. Determine whether g has a relative min, relative max, or neither a min or max at the point, and justify your answer. So you need a statement for justifying. The graph of g has a horizontal tangent line where g prime of x equals f of x equals 0. This occurs at x equals -1. I should zoom out. X equals -1, right there, and x equals 1. G prime changes signs from positive to negative at x equals -1. Therefore, g is a relative maximum at that point right there. Because we're going from positive to now below, so now we're negative. So that becomes a maximum. Over here, it does not change signs because we're below, so we're negative, and we are still below to the negative. So we're neither a relative max or a relative min. Last one. I'm not even going to read it. I'm just going to read the answer. The graph of g has a point of inflection at each of x equals -2 and x equals 0 and x equals 1. So we have 3 points of inflection. And you also need to explain your answer in that one. So because g prime equals f G double prime equals F prime changes the sign at each of these values. That's all I have to write for the explanation. I'll give you a second. You're already on the next one. Okay. Good. Okay, that's really fine. How are we doing so far? Are we grading it as we go with how they do it? Okay. Okay, number 4. I think we've all seen a problem very close to this before. Yeah? Yes. Okay. The function f is defined by this integral from -5 to 5. When you see this, what do you think about? Nothing pops in our head. We have seen this exact integral several times before. You did the integral of this on your last test. And you used, yes, a half a circle, right? We use a semicircle for these types of problems. Okay. Scooching down, which you can't use for that one. That is a different integral. Can't use a semicircle for that one. We should use u sub. Okay, find f prime of x. We could have done it that way. Okay, that should be our statement. If it zooms, boom.
If you don't simplify it, that's the way.
What did you get?
I did -2x over 2 times root 2 from 6.
I would simplify it. They're really picky about simplifying. So yeah. Especially with the 2's. Okay. You didn't have to put in -5 and 5. But I feel like if you did do that, if you got to like that point in it, I think they would still be fine. Yeah. Okay. Write an equation for a line tangent to the graph of f at x equals -3. So put in -3 to our f prime, and we get 3 over 4. And 4. So that's our write an equation. Okay, that's when we get our equation. 4 goes out front plus 3/4 times x plus 3. Cool. Been a long time since I've done equation for a tangent line. Okay, third one. We are going to limits. Let g be the function defined by that above. Is g continuous at x equals -3? Use the definition of continuity to explain your answer. So, did we do limits? Yes. What did you all write for your statement? Anybody? I like yours better than theirs. I don't like the explanation. It's really short. Yeah. Cool. A better explanation, long explanation, is better than a shorter explanation. Okay. Last one. Find the volume of this function. It has an x out front, so sadly we cannot use the semicircle thing. But we can use u sub. So we should have set what is ever under the radical equal to u, which they did. This should have been du. Du goes -2x times dx, and I would change that so dx is out there, which helps us get rid of the x out front when we plug in du. We should have got 125 over 3. Yes, yeah, cool. Okay, almost last one. I am not going to read the problem. This is our function. A, is the bird gaining weight faster than its weight 20 grams or when it weighs 70 grams? Explain your reasoning. What did you find to be the answer? What's your statement at the end?
The bird is gaining weight faster when it weighs 40 grams because it's gaining weight at 12 grams per day. Yeah, I mean 6 more grams compared to if it weighed 70.
Yeah, that's perfect. Great. B, fine. Double antiderivative of, in terms of B. Use this to explain why the graph of B can't represent the following graph. Okay. We should have gotten this as our statement, negative 1 over 25 times 100 minus big B. Therefore, the graph of B is concaving down from 20 to B and B to 100. So 20, that's our bounds. A portion of the given graph is concaved up. That should be our explanation. Cool. Questions? No? Okay. Use separation of variables to find y equals b of t, the partial solution to the differential equation with initial condition of b of 0 equals 20. So we should start off with our equation, separated them, so we have this on both sides. Took the antiderivative. Okay, separation of variables 1 point. Finding our antiderivative is 1 point, so right there. Constant of integrals, sure. Use initial condition, so we're here. So this is my statement. My statement would be 1 point. My use initial condition, so use the fact that b of 0 equals 20. Should have gotten here, so now we have our c. And then solve for b is 1 point itself. And then they have notes here, if you want to look at those. Zero divided by 5 is not separable of variables. Cool. So this should have been our final answer. B of t equals 100 minus 80e to the negative t divided by 5, when t is greater than or equal to 0. Questions on that guy, or the ending of that? No? Okay. We have one more? No. Our free response, which should be short. This was our free responses. Okay, the table problem? Yeah, okay. Sorry, I didn't staple these, so they're just a little everywhere now. Okay, this was the start of our problem. A was use the data in the table to estimate. Use the data in the table to estimate W prime of 12. Show the computation and that leads to answer. Use correct units. Interpret the meaning of your answer in the context of the problem. So that just means they want a statement and they want units in the statement. Okay, first one should have been 1 point. We already did this. Yeah. Which one did we not go over yet? That one. Okay. Okay, from 0 to t of 12, a particle is moving along the x-axis. the velocity of the particle at time t is given by this equation. So we're talking about cosine. The particle is at position x equals -2 at time t equals 0. So we're starting at -2. For 0 to t of 12, when is the particle moving to the left? So that it's moving to the left when v of t is less than 0, which occurs from 3, less than 3, and greater than 3, and less than 9. Cool. Setting this statement equal to 0 is 1 point itself. And then getting our answer is 1 point itself. DB should have just been setting it up like so. Absolute values are important in this situation. Okay, 3. Find the acceleration of the particle at time t. Is the speed of the particle increasing, decreasing, or neither at time of 4? Explain your reasoning. So we need to find the velocity first. Then we need to plug in 4. And then we got our answer to be -√3 pi over 12. Then we go back to velocity. And we find -12. So the speed is increasing at time of 4 because velocity and acceleration have the same time. They are both negative. We need a statement that itself is 1 point. So finding this statement alone is 1 point, and then this is the other point. The work in the middle, sadly, you don't get any points for. Okay, scooching down to D. Find the position of the particle at time t equals 4. So plugging it into our initial position. So our starting position. So we have velocity, we need to go back to starting. So -2 is out front, plus from 0 to 4, integral of cosine of pi 6t dt. So antiderivative of that, we should have gotten that down, evaluate it to equal this statement right there. And it just says find the position, so you don't need to write a statement for this. Antiderivative was 1 point. Using initial condition is another point. And our answer is another point. Do you want me to show you any work for any of the other ones? Of any of the free responses. Do you want me to go back to any? Okay, that's fine. No. Cool. Was it fun doing the AP practice? Okay. The most important thing, which I don't think this class is practiced a lot in, but timing. This is one test. Yes, how was our timing? More than 2 hours. Okay, the good thing is this is kind of like they cut you off at one point, so you can use like calculators for the other portion. Multiple choice. Wait. So I'll show you. Oh, where is it? Okay, here's the scoring guide. We can look at this. All of the short responses are worth the same. So start with the ones you know, skip the ones you don't know for now. Multiple choice is, the whole multiple choice is worth almost close to one of the short responses. Multiple choice is worth a lot less. You don't know it, circle something. Don't leave anything blank at all. That portion's on your computer. So just, if you don't know it, I hope there's like a little tab thingy. At least in most of my tests, it's like a tab thingy where you can flag it so you can go back to it. And you know where you can go back to. But definitely put down some answer as you go. But that's worth a lot less than all of the short responses. That is more important. Short responses. Well, actually, this isn't going on the internet. So yes, I have more. There's more. Okay, he has more. It's more in his folders. So I can show you like a new problem. I'm not supposed to show, but sure. Yeah.